Please confirm if you are able to see my screen and my voice is clear.
Yes, sir.
Okay, fine. So, in the last classes, we were discussing feedback amplifiers. Okay, positive feedback, negative feedback, we discussed. Okay, then advantages of negative feedback. Okay, we discussed advantages of negative feedback, right? These advantages we discussed. Increase in input impedance, we discussed. Okay, now let us once again see how the input impedance increases. Okay, and then we will see the output impedance. Okay, now okay, so right. So here this we have already completed. Okay, change in input impedance we already completed. Just for your benefit, I am explaining again. So here input impedance with feedback will be Vs by Is. Simply input impedance will be input impedance with feedback will be Vs by Ii. Okay, input impedance, simply input impedance Zi will be Vi by Ii. Okay, so Zi will be Vi by Ii, Zif will be Vs by Ii. Okay, then Vi, you know, for okay, negative feedback, Vi is Vs minus beta V naught. Okay, Vi is Vs minus beta V naught. Next, V naught, we can write it as, this is V naught, A into Vi. Okay, so next what we did, in place of V naught, we wrote in place of V naught, okay, Vi is Vs minus beta V naught. In place of V naught, we can write AVi. Okay, so Vi is equals to Vs minus beta A into Vi. Okay, so Vi is equals to Vs minus beta A Vi. Okay, next what we can do, we can send this negative term to the left side, taking Vi common, right? Then cross multiplying. Okay, okay, then we got this relation, right? Okay, what we are doing, okay, so what we are doing here, this term we are bringing to LHS. This term, right, we are bringing to LHS and we are taking Vi common. So Vi into, if you bring this one, right, already 1 Vi. So 1 plus, there is A beta minus, when you bring to the LHS, it becomes plus, isn't it? So plus A beta, simple maths. Okay, simple maths. So we are getting this relation. Next, what we are doing, we know that voltage by current gives impedance. Okay, so our target was finding input impedance. So what we are doing, we are dividing by II. We need to divide by II. So Vi by II will give Zi. Vs by II will give Zif. Isn't it? Zif is Vs by II. Zi is Vi by II. Okay. So we are dividing this by II on both sides. This we are replacing by Zi. This we are replacing by Zif. Okay. So we got Zif is Zi into 1 plus every, right? So gain is increasing by a factor of 1 plus every factor, right? So what is the advantage of increasing. Uh, okay, so this input impedance with feedback, input impedance with feedback is increasing by a factor of 1 plus a beta. Right. So what is the advantage of that? Last class I have opened one software and I have explained. I want answer. What is the advantage of that? When input impedance of amplifier is high, okay, the internal losses will be low. Okay, so that is the advantage. So internal loss is less means overall the output will be high. Right? So it is an advantage when the input impedance is high. Next, change in output impedance. Okay. Now, to understand this one, okay, to understand this one, first we have to see how an amplifier, okay, looks like. See, we have been talking about input impedance, okay, output impedance, voltage gain, current gain. Using this, we can construct, okay, we can construct a amplifier. So this is how an amplifier looks like. Okay. So this is how an amplifier circuit looks like. See, Vs Rs is input. Okay. Vs Rs is input. RL is load. Remaining everything is amplifier. So what does your amplifier block consist of? Here three components: Ri, AVBI, R0. Okay, only these three components, right? In simple words, see, we say that an amplifier has input resistance, okay, Ri, then it has voltage gain, okay, AV, right? Voltage gain or current gain, okay, right? Or both. Anyway, so we are representing here in terms of voltage gain. Then out resistance. Okay. So what I am trying to say is, this is how we can represent a amplifier. Okay. An amplifier we can represent by these three components. We can represent an amplifier by these three components: Ri, AVBI, R0. Okay. Now, why we need this is to derive the expression for output impedance. We need that circuit. Okay, that's the reason we are discussing that now. Okay. Now, what are the rules for output impedance? Please answer. Same old rules that we discussed in first unit. What are the rules for? Yes, please answer. Fast please. Output impedance. How to find output impedance? What are the rules? Fast please. Easy question. This we might be discussed so many times while studying first unit. Okay. Yes. What are the rules for finding output impedance? Okay. Fine. This is a typical amplifier. We told you. Okay. discussed. For finding output impedance, right? The rule is RL. What we should do to RL? What should be done to RL? Yes. What should be done to RL?
Open circuit.
Very good. RL is open circuit. Then source voltage, what we should do?
Close circuit.
Source voltage, we should make it 0. Okay, replaced by short circuit. So, anyway, see, we are okay. So, now go to our let us go to our block diagram. Okay, right. See, this is the block diagram we have to see. Okay, this is the block diagram we have to see, right? So one is the RL we will replace. Okay, RL we will open circuit. Okay, RL we will open circuit, and VS we should make it 0, right? Okay. So if if VS is becoming 0, what is VI? Nothing but if VF is if VS is becoming 0, then what is VI? Nothing but from this relation. What is this? Nothing but a rule for finding output impedance is make source voltage 0. If you make source voltage 0, source voltage we are making 0. Okay, I hope this is clear. We discussed this so many times. Okay, rule for finding output impedance. Okay, so again I am stressing again. I see same thing. One time we will take the concept, we will implement it 100 times, right? So this is our subject. We will learn only once, we will implement 100 times. So we are discussing output impedance. Rule for output impedance is we will make source voltage 0. Okay, source voltage we will make 0. So if you make source voltage 0, what is VI? Answer please. If VS is 0 here, what is VI? Nothing but easy question. Fast please. Yes. Yes, fast please. Easy, very easy question. Okay, it's not at all difficult. Quickly answer. First, see, we cannot keep wasting time like this. Okay, fast please. Yes. Okay, so for finding output impedance, one of the rule is Vs is 0. When Vs is 0, Vi is equals to minus, okay, Vs if you put in this relation, if you put Vs 0, okay, if we in this relation, if you put Vs 0, Vi is equals to minus beta V naught. Beta V naught is nothing but Vf, feedback signal, isn't it? This is the feedback signal. Beta V naught is nothing but the feedback signal. So for finding output, okay, for finding output impedance, one relation we got is Vi is equal to minus beta V naught or Vi is equals to minus Vf. Okay, this is one relation we got. So one relation we got is Vi is equals to minus Vf. Okay, right? Or Vi is equals to minus beta V naught. This is one relation we got. Now to get the other relation, we have to see this circuit. Okay, we have to see this circuit. Now, any amplifier we can represent like this. Okay, Ri, ABVI, R0, right? Already I told you. So here, so for finding V0, what is the rule? Replace this, okay, open circuit RL, connect external source V0, then current drawn from the source, okay, we have to measure. So in this case, what will V0 be equal to? This is V0. Current drawn, let us call it I0. Okay, the current drawn, let us call it as I0. So V0 will be I0 R0, okay, plus ABVI. Okay, right? V0 is equal to I0 R0 plus ABVI. Okay. Some textbooks, some authors will take it as Z, some will take it as R. Okay. Whatever in the question, if they ask impedance, then same you will put Z. If they say input resistance, then same variation you will put R. Okay. So, right. So here again I am explaining V0 in this case, V0. What is the rule for V0? RL we have to open circuit. Then V0 we will connect a source. Current drawn from the source I0. Okay. So V0 is equal to, then V0 will be simply in this path, the voltages. In this path, the voltages will be, one is drop across this resistor, another is this one. Okay. So V0 will be I0 R0, okay, plus ABVI. I0 R0 plus AVI. Okay. Next, just now we discussed, because source voltage is 0 for finding output resistance, VI is equals to minus VF. Okay. Or VI is equals to minus beta V0, isn't it? Okay. We discussed. So in place of VI, we can write minus beta V0. So remaining everything as it is. Here V0 as it is. Okay. A as it is. In place of VI, we are writing minus beta V0. In place of VI, we are writing minus beta V0. Okay. Then next, this minus term we are bringing to the LHS, it becomes plus, right? So V0 plus A beta V0 is equals to I0 Z0. Okay. Here we can take V0 common. If you take V0 common, 1 plus A beta. Okay. I0 Z0 as it is. So next V0 by I0. How to get output impedance? Output voltage by output current. So V0 by I0. Simply cross multiplying this I0 to LHS, and this 1 plus A beta we are cross multiplying to RHS. V0 by I0 we are getting Z0 by 1 plus A beta. Okay. So V0 by I0 we can call it as R0 F, okay, or Z0 F. Some others may call it as Z impedance. Okay. Same. Just consider it as the same. So sometimes in question they may say find input impedance. right? Find output impedance. Then we should use Z, right? So either you can represent this as R naught F or Z naught F. Anything we can use to it. So any doubts so far? Yes, students, any doubts? Students, any doubts?
No, sir.
Okay, fine. So what is happening with feedback? Okay, the output impedance is decreasing by a factor of 1 plus A beta. Next, classification of feedback amplifiers. See, based on certain conditions, an amplifier is classified as voltage amplifier, current amplifier, transconductance amplifier, trans resistance amplifier. Okay. So what are those conditions? We will see here. Okay. See, if you understand one, you can understand remaining everything. Okay. So concentrate, and whatever question is asked, please think and answer. If I know, see if I know whether you understood or not, isn't it? Okay. Then I can go ahead, isn't it? So, as discussed, this is a general amplifier. Okay. This is a general amplifier. We have three components: RI, ABBA, R0. Okay. Next, here additionally to the amplifier, we are considering it to the amplifier is only these three components: RI, ABBA, R0. To this amplifier, additionally we are connecting voltage source with internal resistance RS, then load. Okay. Now, here, see, it is like this. If this resistance is much greater than this resistance, okay, right? If Ri is much greater than Rs, okay, then okay, easy question I will ask you. Okay, simple school level mathematics, if you can use, is sufficient. See, this is our amplifier. This is the source, internal resistance. We don't want, okay. Now, what is voltage amplifier? Input is voltage, okay. Output is also voltage with minimum losses, right? Minimum losses means we don't want losses. Where are the possible losses? See, one of the possible losses here. One of the possible loss is here. Okay. Another possible loss. Okay. What do I mean? What do I mean by loss is, suppose we have Vs. Okay. Now, if the entire if the entire Vs without loss, if it appears at Vi, then that Vi multiplied by gain will appear here. Okay. But if that is not happening, then there is a loss here. Next, another possible loss is here. Okay. Whatever the signal that is generated the amplified signal, we want this, okay, we want that signal to reach the load without losses. Okay, so the possible losses are here and here. Now, when Vi will be nearly equal to Vs, please, okay, see, no loss means this doesn't have this, okay, this part of the circuit. This part of the circuit has no loss, means Vi is nearly equal to Vs. When will that occur? When will that happen? Or when can we neglect? When can we neglect? Okay, the loss here. Okay, so first let us take the current is II. Let us take the current is II. So current flowing in this loop, let us call it as II. II. So what is voltage across RS equal to? Answer please. Ohm's law. Fast please. Yes, just Ohm's law. Yes, students. Ohm's law. Okay. Current we are calling it as II. Resistance is RS. What is the voltage across this resistance?
II into RS.
II into RS. Very good. Likewise, what will be the voltage here? What will be the voltage here? Voltage here. What will be the voltage here? Here. Same Ohm's law. See, II is flowing into
II into RS.
very good. Okay. So the voltage here is II into RS. The voltage here is II into RI. Okay. Now, when the loss will be less is when this voltage is much greater than this voltage. Okay. So, II RI, if it is much greater than II RS, right? Isn't it? See, when this voltage is much greater than this voltage, okay, then the loss is less. Okay, so what we can say, if IIRI, okay, is much greater than IIRS, then maximum signal will pass. II we can cancel out. One of the condition is RI, okay, RI should be much greater than RS. See, very simple. Very simple. Here, this is a single loop. Okay, this is a single loop. Single loop means the current flowing is the same. Okay, current flowing is the same. So now for voltage amplifier, the challenge is whatever Vs we give here, without loss, maximum signal should come here. Okay, without loss, maximum of Vs should reach Vi. Okay, so for that See, means this voltage, okay, should be much greater than this voltage, right? Okay. So one of the condition is Ri should be much greater than Rs. Okay. See, for example, we can put value. If Rs is 0, okay. If Rs is 0, then Vs, okay, Vs is equal to Va. Fine. But most of the practical situations, we do not have zero internal resistance. Every source has some resistance. Okay. So considering the practical situations, okay, the condition is Ri should be much greater than Rs. Okay. Now same logic here. When will this voltage, okay, when will this voltage reach RL without loss? When will, okay, when will this voltage reach RL without loss here? See, in this case, we discussed that this resistance has to be small. Okay, once this resistance is small, then maximum voltage will pass on here. Likewise, okay, for this voltage to pass on to the load, okay, then similar condition. Here Rs should be small, okay, here R0 should be small compared to R. Is it clear, students? Is it clear? Say yes or no.
Yes.
Yes, clear. Okay, so the condition for voltage amplifier. See, this is general. This could be any amplifier. Okay, this could be any amplifier, but you will call it a voltage amplifier if it satisfies the condition Ri greater than Ri much greater than Rs, or not much less than Ri. Okay, if, okay, if these conditions are satisfied, then only we say that our amplifier is a voltage amplifier. Okay. So ideal case is Ri is, see, Ri has to be large, isn't it? Ri has to be large. Means ideal case best will be large. Highest value is how much? Infinite, isn't it? So Ri is infinite. R0 is lowest value is 0. Okay. So for a voltage amplifier, it is preferred that Ri is infinity and R0 is 0. Next, current amplifier. Here, what we will do is we will do source transformation. Okay, same circuit. We will go for source transformation. Source transformation means a voltage source in series with a resistance. What is source transformation? Please answer. A voltage source in series with a resistance, we can represent it as a what? Current source in, answer please. Yes, please answer. A voltage source in series with a resistance is equivalent to current source in parallel with the resistance. Okay. So VSRS we can represent in terms of, okay, a current source, then in parallel with a resistor. Okay. Now again, if, okay, if this has to work as a current amplifier, means whatever the current that we are generating here, they should not, it should not flow through RS. It should flow through this one. Okay, right? Why? Because this, okay, it is this current which is reflected on the other side. Okay, the current through RA. So if the if the IS, okay, that comes here, if maximum of that IS has to flow through RI, you know that current takes always prefers low resistance, right? So RI has to be much less than RS. Okay, so RI has to be much less than RS. Now, again, okay, again here, if we consider the input side, we did source transformation. Even at the output side, we can do source transformation. This is like a voltage source, resistance. Okay, we can represent it by a current source, then parallel resistance. So now again, the current that comes here, it has to pass to the load, okay, without loss here. Means this resistance has to be much less than R. Okay, so the condition for current amplifier is, for an amplifier, if input resistance is much less than source resistance and the output resistance is much greater than load resistance, okay, then that amplifier is called as a current amplifier. Okay, so ideal case, RI has to be 0, R naught has to be infinite. RI has to be 0, R naught has to be infinite. Okay. So we will stop here. We will continue in the next class.